and welcome to AP Calculus 5.1 Logarithms. When we're looking at logarithms, it's important for us to refresh our memory on the definition of a log. Remember that all logs can be written in an exponential form. You've got properties of logarithms. Now, when we look at these properties, we're used to going a certain direction. Well, in AP Calculus, we're actually going to be going in this direction. Now, in Algebra 2 and Pre-AP, we usually went from the right side, many logs, into one log because we were trying to solve logarithmic equations. So we wanted one log on the left, one log on the right. Well, with calculus, we want to get rid of products, quotients, powers. Not that we don't like them, but remember the product rule, the quotient rule, that wasn't as much fun as the power rule. So in AP Calculus, we are going to usually take a product, a quotient, or a power, and we are going to rewrite it so that it will be easier for us to take the derivative. Be very careful when you are doing your notation. Make sure fraction bars don't slide underneath our logarithms because those mean different things. Also, when you're looking at a logarithm, anytime something is multiplied together, you won't need those extra parentheses. Sometimes they'll write them, sometimes they won't. If, however, something is added or subtracted, you have to put the parenthesis there or it will stop at the plus or minus sign. So if it's multiplied together, you're good to go. So please review your properties. And we're going to do a little example. Like I said before, in AP Calculus, we would like to take the derivative of things that are smaller. So if you just look inside the parentheses, you've got a product rule, you've got two product rules, and you have a quotient rule. After we use our properties to separate, remember that minus sign just means those are the ones on the bottom, and you may see this all written out without the parentheses, and that's perfectly fine. Just as a general rule, if you see something that is minus, then that means you were on the bottom. Negative, you're on the bottom. Or you can do the parentheses and distribute later. So on number 2 here, let's go ahead and practice rewriting this. So if I have log base 2 of x to the second y to the third z divided by x plus 1, we're going to go ahead and expand that. So first of all, we're going to split at the fraction bar. So everything on top. And then everything that was on the bottom is subtracted. Then these are all multiplied together, so I'm going to separate those with addition. And the last thing I will do is bring those powers down in front. When you're going through these problems, please make sure that you're not losing a base. Sometimes they start off as base 2 and then eventually we lose that. So 2 times log base 2 of x plus 3 times log base 2 of y plus log base 2 of z minus log base 2 of x plus 1. Make sure that x plus 1 stays in parentheses so that you're taking the log of that entire quantity. Final answer. That's as good as it's going to get. So when we take the derivative of logs, you've got log base e and then you've got every other base. So log base e is basically our favorite. When you look at your log, you're going to look to see what you're taking the log of. So when you take the derivative, you are going to write 1 over what you're taking the log of. This g of x, whatever that function is inside the log, that's exactly what it's going to look like on the bottom. And then you're going to multiply that by the derivative of what you were taking the log of. So it creates a chain rule every time you're doing a log. So looking at our examples, y equals the natural log of 4x plus 3. When I take the derivative, dy over dx, remember that is the same thing as y prime, you're going to take 1 over what you were taking the log of, so 1 over 4x plus 3 times the derivative of what you were taking the log of, which is 4. And then this is a fraction. Remember, this is 4 over 1, so go ahead and rewrite it so it's a nice pretty fraction. Do any simplifying that you can. This is in its simplest form, so we are good to go. If, however, you don't have a base of e, you're going to start off your process with 1 over the natural log of the base you do have. Now technically we have that here, 1 over the natural log of e, but you know the natural log of e is 1, so you have 1 divided by 1, which is 1. So this has just been simplified. So basically this formula is going to work for all of your logarithm bases. So 1 over the natural log of the base you do have times 1 over what you're taking the log of times the derivative of what you're taking the log of. So looking at our example 4, we have y equals log base 4 of 5x. We start the party off with 1 over the natural log of the base we do have, which is 4, times 1 over what we're taking the log of, times the derivative of what we're taking the log of. We have our 5's, those canceled. We do want to make sure that we simplify this as much as we possibly can. So looking at an additional answer, our question, we have y equals the natural log of x plus the square root of 4 plus x squared. Now there's nothing we can do to simplify this. Remember, if we have a product inside here or a quotient inside here, we can use those properties on the first slide to simplify that. But we have that nice pretty little plus sign there, which stops us from doing that. So we're going to go ahead and take our derivative. We're going to take 1 over what you're taking the log of times the derivative of what you're taking the log of. So times the derivative of x is 1 plus, remember the square root of 4 plus x squared is a chain rule, so that power is a 1/2, so we're going to bring that 1/2 down in front. We're going to subtract 1 from the exponent. So that's a negative 1/2. And then we're going to multiply by the derivative of what's inside, which would be 2x. When I'm looking at this, I do have 2 terms now. I want us to see we've got one term here, and then we've got our second term up here. Our second term has a negative exponent, so we are going to need to move that down in the denominator of that term only. So we're going to create a complex fraction. We do have a 1/2 and a 2, so those do cancel each other out. So let's do that. We've made that look a little nicer. So we have our 1 from our first term, plus we still have an x left in the numerator, and then our denominator is now the square root of 4 plus x squared. That's this guy right here. We've moved it down in the bottom, all divided by the original denominator that we have. We do not have to get a common denominator if we are looking at a multiple choice problem. At this point, we would look at the distractors and see if they've gotten a common denominator to see if our answer is the same as one of the distractors. Unless you have to get a common denominator, I probably wouldn't. Now on problem 6, this problem, make sure you realize that how it is written, the parentheses would actually be right here. So that means that -7 is not inside that log. So we do have a product rule. This is a product rule on the outside, so that means we do not, got a little excited there with my underlining, there you go. So we are going to have to do the product rule. If we had something like the natural log of 2x times the sine of x, something like that, then we could split it apart and make this a little bit easier and avoid a product rule, but we don't have that. So we are going to have to deal with that product rule as we have it. So here we go. We're going to take the derivative of the first times the second as is, plus the derivative of the second times the first as is. All right, let's see if I can keep track of my pins here. So the derivative of sine is cosine of x, times the second as is, don't change a thing, plus the derivative of the second, which would be 1 over what I'm taking the log of, times the derivative of what I'm taking the log of, and I'll simplify that all in the next step. You're going to find that if you try to simplify too much in one step, you're going to get confused and go cuckoo. When I'm looking at this, the derivative of -7 is 0. I'm just going to put it in there to remind myself that I have taken the derivative of everything. So I've got two terms here. This was my first term. This is my second term. So that first term was a product rule, derivative of the first times the second as is, plus the derivative of the second times the first as is. I do want to simplify this. So cosine of x, natural log of 2x, plus the 2's are going to cancel, so I have sine of x over x, and then of course we're not going to write that 0 anymore. So this is my simplified answer, and that is a beautiful thing. Example 7 and example 8, you're going to work those, and then you're going to look at the second video for section 5.1, and I'll go through those problems. Now, when you're looking at example 8, make sure that you use your properties to make this a lot